Good evening, everybody. This is a live emergency briefing as we have a big-time severe weather event expected on Sunday from central Oklahoma into north Texas, as a very potent upper-level storm system is going to eject and mix east a dry line all the way to the I-35 corridor by evening. Right now, it looks like the main severe weather is going to be most widespread just after sunset, so it very easily could be a nocturnal severe weather event, but I do think there is a very decent chance of diurnal convective initiation. But as far as I'm concerned, I storm chase whether it's daylight, whether it's nighttime, doesn't really matter. I'm going to be chasing all night, Sunday night, this system, I-35, eastern Oklahoma, down into northeastern Texas as well. Could see a number of tornadoes as well as that low-level jet is forecast to really ramp up Sunday night. And we're still watching Tuesday, that massive trough ejection. The Storm Prediction Center does have a risk for severe weather on the day 5 outlook, and that's going to be Tuesday. And then that system launches off to the northeast, bringing severe weather with it across eastern Iowa, maybe up toward Illinois. That's a little bit more uncertain right now, as it looks like that trough ejection could be pretty rapid off to the northeast. But I also wanted to provide a little bit of an update here on the sea surface temperature situation in the Pacific Ocean, as it might have played a role a bit in this active second season, and probably a very active spring season 2022 is also anticipated. We still do have this La Nina continuing to dominate the tropical Pacific Ocean. You can see these negative anomalies. Those are on the order of -2, even -3 in spots there, straddling the equator as well in the tropical Pacific, and different than spring of 2021 that had a lot of warm water here in the subtropical branch of the Pacific Decadal Oscillation. So this horseshoe shape, blue right there, that's called the PDO horseshoe, and the Pacific Decadal Oscillation, and it encapsulates the North Pacific Oscillation within it, which is in a positive phase with that warm water there in the North Pacific. But it's this cold water here in the Gulf of Alaska, the far North Pacific, and wrapping around into the subtropical branch that is also quite crucial, in my opinion, in setting the wave train and also consolidating that jet stream. So it's not just the tropical Pacific anomalies, but they also modulate the North Pacific anomalies. So when you get these very cold anomalies, or on the flip side with El Nino, when you have warm anomalies in the tropical Pacific Ocean, then you get these Kelvin waves that just feed this Pacific Decadal Oscillation horseshoe. So usually the PDO horseshoe sign, especially the subtropical branch, will often lag an El Nino or a La Nina event that happens in the Pacific Ocean by a year or two. So we had a lot of warm water in the spring of 2021 here in the subtropical branch of the PDO, and a lot of that was from the preceding El Nino conditions that we had in the tropical Pacific Ocean, with those warm sea surface temperature anomalies propagating around the eastern basin here, this ring that is the PDO horseshoe. So I believe that different than the year 1 La Nina coming into spring 2021, the year 2 La Nina, that's why these are a lot more favorable for severe weather in North America, because it begins to populate this PDO horseshoe with negative anomalies from the La Nina conditions dominating the Pacific Ocean. So that's why I think it's going to be an active second season here, which we're right in the middle of. We're about to see that come to fruition starting on Sunday. This right here is the latest 18Z operational GFS. And looking at the operational models here, let me shrink this down a bit so that you can actually see the whole entire view here on the GFS. And it shows that trough that is quite potent. Right now it is over California, and does have a lot of flow on the east side of it, but it also has a lot of flow on the backside, and that system is expected to launch with a neutral tilt. Perfect configuration to get a big-time severe weather event, and that's why the Storm Prediction Center does have that enhanced risk in place, central Oklahoma into North Texas. And here you can see the main system Friday afternoon and evening here. A lot of flow on the east side of this trough, but you can also see a lot of flow here sneaking in on the backside of that trough as it moves on shore here to California. Really gets potent over the weekend on Saturday. A lot of flow here getting stretched out over top of this subtropical high. Anticyclone over South Texas into northern Mexico. So you get a lot of strong flow there squeezed between the two, with a little lead vortex over the northern high plains approaching the Dakotas. But it's this main vortex here, this main lobe right at the base of the trough over California tomorrow. That's going to be the main system that's going to bring a dry line severe weather event to Oklahoma. So let's watch that as we step forward 24 hours. Look at it intensify, and it's really trying to gain this neutral tilt, going from a positively tilted but very potent vortex at the base of it to this neutrally tilted compact lobe of vorticity, perfect to excite a due southerly low-level jet out ahead of it. And this is at 18Z peak mixing, and that low-level jet intensifies as that vortex moves from west to east, ejecting from the Four Corners region across the southern plains. And let's zoom in on that now. Zoom in on the southern plains so that we can see that big time trough that's ejecting. Here you can see the very compact 850 low that you would expect with a favorably shaped 500 millibar trough with a neutral tilt ejecting from the Four Corners region over the southern plains. And this low-level jet downstream is what you want to watch. This is what's going to intensify from 21Z to 0Z, and then especially overnight. But at 0Z, look at this ramp up. You're talking about 40 to 50 knots there, about a kilometer above the ground. It's a very strong low-level jet, and you kind of have this egg-shaped but very compact 850 low, backed low-level jet off to the east of it. And also this vortex, as it ejects, is going to cause the low-level jet to intensify even more by 3Z. Look at this, in excess of 50 knots there across eastern Oklahoma. And that's why there is that enhanced risk, including the threat of tornadoes, some strong tornadoes here with this nocturnal tornado event. I would certainly have a hatch area out with the potential of strong tornadoes, because if there is a tornado in this environment with 50 to 60 knots, about a kilometer above the ground, that tornado is going to cause problems and likely will be a strong one. I don't see an outbreak of a bunch of weak tornadoes with a setup like this, with a low-level jet ramping up to 50 or 60 knots. And then as we go toward midnight, notice how it's not a really rapidly progressive system, but that western edge of the axis of that low-level jet still in far eastern Oklahoma over a 3-hour period. So you are going to have some relatively faster storm motions than we thought that we'd see before. And that's because of an 80-85 knot mid-level jet streak punching in to Oklahoma like the end of a ski jump right at 3Z, and it actually arrives right at 0Z about 7 p.m. So this is what's going to initiate storms probably in southwestern Oklahoma down to northwestern Texas at about 6 p.m. And these are going to rapidly approach the I-35 corridor by 0Z or about 7 p.m. here. But this is just the 18Z GFS, so still a little bit can change with the timing here of this upper level trough. Let me see if we're within range of the HRRR. And we are at least relatively close. Here is the HRRR at 18Z. So this is about 6 hours earlier, showing you that jet streak rounding southeastern New Mexico, moving across the panhandle. And it's this jet streak that rounds the base of this trough. It's gaining a neutral tilt, and it's going to slingshot this jet streak into Oklahoma right at about 0Z. And that's going to be when I think that storms are going to initiate, probably a little bit before that as well. Looking at the 3-kilometer NAM, roughly a similar position here with that jet streak over eastern New Mexico, midday on Sunday. So it is very possible that this could be a nocturnal severe weather event. Looking at the same time here, 18Z GFS, you can see how much more smooth all these features are with the global models. But you can see this jet streak maybe a little bit faster on the GFS, might be just a little bit slower on the high resolution models, but really not that much. They're about the same. 18Z HRRR going out 48 hours, waiting on that 0Z information here. 3-kilometer NAM looks to be a little bit slower than the other models. So the timing of this jet streak is definitely going to be critical as to when it initiates those storms. So let's see what the 3-kilometer NAM says. And I did expect the NAM models to get a little bit closer to the GFS, but then the thermodynamics will definitely come out in the 3-kilometer NAM and the HRRR as we get a little bit closer to the event. But this is at 0Z, 3-kilometer NAM, one of my favorite high-resolution models here. And it is relatively close agreement with the GFS. But boy, does it have the instability axis remaining south, at least here as of 0Z, southwestern Oklahoma down into northwestern Texas. This is a 0 to 1 kilometer EHI, basically showing where that surface base instability overlaps with the strongest 0 to 1 kilometer storm relative felicity. And also notice this belt developing in eastern Texas, and I wouldn't be surprised if we see a nocturnal event down there deep into central Texas as well. You often get those lead confluence lines that will develop down there, central South Texas. Even an indication of a pretty strong low-level jet extending all the way down into the southern Texas hill country. But you can definitely see this area here in Oklahoma starting to expand into central Oklahoma by 2Z, about 9 p.m. According to the 3-kilometer NAM, it does look like this is going to be a nocturnal event. Central, southern Oklahoma here into North Texas. And that's why that enhanced risk is so far east, because many of the models are not showing storms initiating during the daylight hours over southwestern Oklahoma. But these storms are going to rip off this boundary, move into that intensifying low-level jet. You can even pick a couple of soundings down there near the Ardmore to Durant area. Absolutely perfect photograph. 50-knot low-level jet there, so a very massive looping photograph, as you'd expect here with a very, very strong wind shear. Let me take my head away from that photograph so that you can see it. And there you can see that photograph. Very favorable for tornadoes because you have a near 90-degree critical angle there. Storm motion vector makes that with a 0 to 1 kilometer shear vector. Strong low-level jet, about 50 knots just above the ground. South-southeasterly surface winds. You do invade that quadrant just a little bit. Some easterly component. You're not really going to need it though, because then you flip to west-southwesterly aloft. Very stout elevated mixed layer in there too, coming in the mid-levels. Mid-levels of the troposphere. Elevated mixed layers are very important for severe weather, no matter where it's happening, whether it's happening in the Mid-South, Tornado Alley, high plains. Maybe not as critical for the high plains, certainly. So this is at 3Z, so now for fun, let's just see where the 3-kilometer NAM shows convection. I'm not really seeing any holes in that Cape pattern, so it is very possible that the 3-kilometer NAM doesn't show anything. But, oh, it does! Shows a mega squall line there at 3Z. And it does show that by 0Z, convective initiation over southwestern Oklahoma being indicated by the 3-kilometer NAM. So look at that big-time tornado producer that the 3-kilometer NAM is showing. Southwestern Oklahoma, 0Z, 7 p.m. It's obviously going to initiate earlier than that. Looks like it initiates in the southeastern Texas Panhandle near the Childress area by about 6 p.m. Rapidly matures into southwestern Oklahoma. And right in the nose of that low-level jet as well, right near that 850 low. Interestingly, the 3-kilometer NAM is further south of that 850 low than the slightly faster GFS. And it's been like that since yesterday, really since the NAM has had this storm system within its forecast envelope. But that's interesting. I wonder if this 850 low is going to come out a little bit further north. You can hop on over to the GFS. And look where it has the 850 low in western Oklahoma. So that's a pretty big difference with the 3-kilometer NAM. I suspect, though, that this high-resolution model is going to trend a little bit toward the GFS, at least with the placement of these main features. But by 0Z, you can still see the nose of this low-level jet punching right into that storm in southwestern Oklahoma, according to the 3-kilometer NAM here. Nicely backed, intensifying low-level jet by 0Z. By 8 p.m., just a ripping low-level jet there, about 50 knots into southwestern Oklahoma, feeding right into that storm, too, that's going to be heading from southwestern Oklahoma towards central Oklahoma with an intensifying, backing low-level jet out ahead of it. That is a recipe for big problems. It's probably going to produce a couple of tornadoes, and then it shows this lining out and then having tornadoes embedded within it. Anytime you get this big 50-knot low-level jet here, looks like that's ahead of the storm. No upward, like astronomical upward vertical velocity is being indicated. That would suggest that this is a tainted sounding. Let me shrink that just a little bit here. It's probably the inflow is being exacerbated, though, by the presence of that supercell in this convective allowing model. But boy, what a beautiful photograph. Look at that. You've got a 1 kilometer wind of 50 knots. You've got your 4, 5, and 6 kilometer winds. Strong, 40, 50, 60 knots out there. Even pushing 80 to 90 knots a little bit further up. And you got a storm motion of about 40 knots. due northeast, making an angle of 71 degrees. That's more than sufficient. Anything larger than about 60 degrees with this long of a shear vector, even 40, 45, 50 degrees would be more than sufficient to still have that streamwise vorticity intake in the lowest kilometer of the storm. But all of that area contained within that hodograph there is proportional to the storm relative helicity that's going to be available. That's the elk herd. Elk herd is going berserk outside, so Gizmo is also going nuts. The elk are in rut. It is the fall season out here, and I just passed the elk herd as I was coming in. And they're right out in front of my apartment. I can hear horns clashing and everything too. Even worse sounds than that sometimes. But it is rut season here in the fall, which is pretty exciting. Let me make sure I'm still live on here. Looks like I am still live. Good. But yeah, you can definitely hear them making noises out there. Gizmo goes nuts. She wants to naturally herd all of the elk, but they are certainly out there as we're breaking down the 18Z 3-kilometer NAM. I think we're going to see a shift to the 0Z, and especially tomorrow morning in the 12Z, a little bit further north of this 850 low, and that would bring northern Oklahoma into play. The majority of the state of Oklahoma there into play as well. And so then this squall line is going to really consolidate with that ramping up low-level jet and then march off to the east through eastern Oklahoma. Embedded circulations within this, QLCS tornadoes. It's very possible it won't transition as quickly into a line either, as is indicated by the 3-kilometer NAM. Probably going to see some isolated supercell storms developing all the way down into North Texas as well as this happens. But a lot of times the 3-kilometer NAM will do this. It will rapidly initiate a squall line like this when they'll maintain individual supercells a little bit longer. 3-kilometer NAM even shows a Del Rio storm developing down in the South Texas Hill Country. Shows the potential for more isolated storms developing down into North Texas a little closer to midnight. If you live in Dallas, this will probably be a night where you're going to want to be glued to those severe weather watches and warnings well into the late evening hours. And I do think there's a chance some of these prefrontal convergence bands could also develop into supercells additionally. So it doesn't look like convective initiation is going to be an issue at all. And in fact, the GFS even shows individual supercells a lot more favorably than does the 3-kilometer NAM. So I think we're going to see, and that's because that further north track of the 850 low, everything a little bit more in line and showing those supercells all the way down to Waco, Austin area by late evening as well on Sunday. So this is going to be a big event, everybody. Now GFS initiates storms up into central Oklahoma. That instability axis dry line up there as well. Initiate storms central Oklahoma down into North Texas. You got these upper 60s dew points streaming into southern Oklahoma, all the way up into central Oklahoma, east of the dry line. So this looks like a very favorable severe weather event. I'm going to hit the road tomorrow in Dominator 4. I'm going to be putting some flex tape all over it as well. I'm also about to start a live stream with Gizmo highlights over the last couple of years. So Gizmo actually makes her debut on Storm Rising on National Geographic Television Sunday, 10 p.m. Eastern, 9 p.m. Central. So Gizmo is going to be on TV in the Dominator van. I haven't seen the episode yet, but I'm pretty sure that she makes an appearance big time in episode 2, unless they cut it out at the last second. But she was in the Dominator van the whole entire time as we were intercepting tornadoes and gorilla hail out there. So excited for that on Sunday. But I'm going to be storm chasing Sunday night. This is right about the time that Storm Rising airs. And you've got 70 plus dew points streaming in from North Texas into the Durant area, up through eastern Oklahoma. Even Tulsa gets into the mid and upper 60s dew points there, northeastern Oklahoma. Bulging dry line ahead of that surface low into central Oklahoma there. Finally pushing through Oklahoma City by about 10 p.m. So let's see what the regular NAM shows for positioning of all these different features. And the regular NAM is a little bit slower. You'd probably want to bring that enhanced even west of the I-35 corridor if you're a NAM fan. upper 60s dew points here dominating. It is a little bit further south of the 850 low, very similar to the 3 kilometer NAM, kind of a halfway average between the GFS and the 3 kilometer NAM. So with such a compact lobe of vorticity like that that's ejecting, there are going to be little differences between the individual models and timing of these main features, positioning of the 850 low, very compact vortex here that's ejecting from the four corners across the southern plains. Perfect for getting those compact triple point dry line type setups that often happen in Oklahoma during the fall season. So, and in the early spring, you may remember the Hammond, Oklahoma setup here, dry line setup, early March, that happened as well. So this is gaining a neutral tilt, very compact lobe of vorticity here. Jet streak whipping around the south side there. The timing of that jet streak reaching the dry line is going to be critical to determine when initiation happens and does it happen during the daylight hours. But that's the NAM. Let's look at the GFS 500 millibar vortmax position. And that's the difference. The NAM has it slower, a little bit further south. The GFS a little bit faster, northeastern Texas panhandle. But both of them have this potent jet streak whipping around the southeastern side. It's just whether storms initiate in southwestern Oklahoma along the dry line, according to the NAM model, 3 kilometer and regular NAM, or does it initiate along the dry line closer to central Oklahoma near I-35, as per the GFS model. European model is a little bit faster as well. I tend to believe the timing of the GFS model, the global model. The storm system has just come on shore in California right now, so I think that the 0Z NAM should trend a little bit toward the GFS model here. And then there's that Vorta 18Z about 6 hours before the time I just showed you. Looks like the HRRR might be a little bit closer to the GFS with the positioning of that Vort in northeastern New Mexico. So it does look like that model is a little bit closer, but the timing of that jet streak is going to be critical. I think it probably develops in southwestern Oklahoma, and then they mature as they approach the I-35 corridor by about 7 or 8 p.m. So let's just see for fun what the 18Z GFS now has with a big-time kicker system. A lot of flow on the backside. Storm Prediction Center also has a risk for this one. This could be a more widespread severe weather event. It's a bigger trough in size. A lot of flow here on the backside telling me that it's still deepening on approach to the Four Corners area there. That's Tuesday morning already, so it is moving a little bit slower. Slowing down as it's approaching the Four Corners. My friends who are talking about the northward trend of this bowling ball, though, notice how it's hugging, if not trending even a little bit further south with this massive bowling ball of cold air aloft in the troposphere. Not surprised at all about that. And it does seem to be slowing down just a little bit, but not that much. A lot of flow here out over the southern plains. A big-time bowling ball of a vortex here, ejecting from the Four Corners up toward Colorado here. A lot of flow downstream. Looking at that low-level jet. Big-time low-level jet. Nebraska all the way down through Kansas, Oklahoma. Big severe weather event. It all depends on how rapidly that moisture is able to get that far north as to how big this system will be. And boy, look at that. Dry line set up. Western Oklahoma, western Kansas, into southern Nebraska as well. Big dry line mixing off to the east near the Texas-Oklahoma border there. Just a massive instability axis that's expanding in size as we're getting closer to the event. So the trend is for even more substantial for Tuesday for this. And look at that near Dodge City. Let's take a sounding near Dodge City. It's probably a PDS. It's like saw a professor that was just flipping out on Twitter today saying that they saw a fake Outlook with a NOAA logo on it, but they didn't identify the actual account. Usually when that happens, that it could be an attention-seeking moment, where you're trying to kind of feed on the hot topic of the moment, and you know that your peers feel the same way, get a little bit of traction from it. So I asked to identify the account, and it hasn't been identified. I know there were some jokes going around in the last day or two with some outlooks from the 2014 big time high risk, but it clearly said day 1, and it was about 4 or 5 days before the event. So I think it was pretty obvious that it was a meme type of a thing, but drama always ramps up when you get these big severe weather events like this, or when hurricanes are about to come, an active hurricane season or an active severe weather setup. Meteorologists, everybody gets fired up, storm chasers, and the reason why is because we're really all weather weenies at heart. No matter how important somebody thinks that they are or wants people to think that they are, we're all just weather weenies, excited about severe weather, interested in studying it, chasing it, forecasting it, monitoring every single forecast model that comes in. And I can understand too, that it might get confusing if leading right up to the event, if there are a bunch of fake outlooks that are really misleading that are coming out. But in this case, it appeared to be weather enthusiasts just joking around, throwing out some memes. So to me, it didn't seem like an issue. It also could have been completely fake situation to kind of get ahead of the potential for fake outlooks that might come out. But I've never really seen fake outlooks as too much of an issue out there yet. I don't think it'll be an issue. I think everybody has their opinion about forecasting. Computer models do a great job. So I think once you kind of have the human interpretation of these models, sometimes it can even reduce the quality of the forecast a little bit. But those opinions still do matter because these models aren't a perfect representation of reality. And it's still possible to pick up on certain biases or certain patterns within these models, especially those of us that look at these every single day. You can easily start to pick up patterns. And as weather enthusiasts and weather weenies, I think that we're pretty naturally adept at identifying patterns within a series of numbers or a time series of anything. Oh man, Sunday looks like it's going to be a big deal. Probably also an enhanced risk, maybe even a moderate risk. And it doesn't look like the second day on Wednesday happens. It's more of a 2-day setup. It definitely doesn't look like a 3-dayer. Those are rare. It's pretty rare to get a 3-day setup, but it does look like the GFS shows a potential locate high shear type of a setup here. So I'll have to keep a close eye on this one as well. And there's also a hurricane that might head down toward the Acapulco area. Some of the models are showing a decent hurricane down there, right near that horn area. But it also could curl into that concave area of the shoreline and then weaken when it comes in. So could always head down to Mexico and intercept that hurricane. But I'm in tornado mode, I think. I know I'm in tornado mode here. But yeah, look at that big hurricane down there. The GFS shows coming in Wednesday evening. So it could be possible to chase both Sunday, Tuesday, and dip down there and intercept that hurricane as well. Most of the models do bend it in toward the coastline, but like Patricia is a really powerful hurricane. They can weaken if they approach that rocky coastline a little bit too slowly. See if I can see the Pacific side out there. So there you can see that hurricane. That's Wednesday morning. And it does bend back toward the coast as we go through the day on Wednesday. But there's the coastline, and see how this thing is curling in? The coastline bends back into the east, and so if it misses this little horn out there, it's going to have some opportunity to have land interaction and then weaken, and then you're talking about probably your Cat 2 type of an intercept. Not necessarily worth going down to intermingle with the cartel down there if it is a Cat 2. And it looks like it stays just offshore according to this GFS run. Might be like a Wednesday night type of a landfall there. And see how it starts to lose its intensity as it's interacting with that concave portion of the rocky portion of that shoreline. Mountains right there as well. Big rainmaker, probably mudslides and whatnot coming right into that portion. But it does weaken a little bit due to land interaction. It's kind of going right along that little tip down there in Mexico. But it does look like it could be a powerful hurricane. A lot of warm water down there. Near Puerto Vallarta, that zone. But I'm definitely going to be chasing tornadoes Sunday through Tuesday. And then I'm going to be pointing the ship toward my mom's in the southern Appalachians to do leaf peeping activities out there. So very excited about that. Teaming up with my mom. Also an expert extreme leaf peeper. Gizmo will be with us. So you could go right there to the point, and then the core will stay just offshore. Then you'll have to make a beeline like 6 hours back north. Terrified a cartel will get you all the time. But if there weren't any tornadoes, then I would head down there in a heartbeat and intercept this and deploy surginators up and down the coastline, subsonics. But it looks like it misses that tip of the coastline, curls in, and then kind of spins down. Initiates way down here in the tropical eastern Pacific and then lifts off to the north. And I do think that we're going to have an active second season here. Basically our year 2 La Nina. Consolidated jet stream there over the northern Pacific. A lot of cold water there too. And when you get these troughs, they'll actually proliferate the cold sea surface temperatures there. You get a lot of cloudiness and a lot of rain, and they can actually make that northern branch of the PDO kind of get some positive feedbacks that'll work in there as well. I had somebody tell me once when I was posting about the PDO on here, which was my grad school research, that they said that it's more the atmosphere that modulates the sea surface temperatures in the North Pacific. But I think that's impossible because there's such a relationship between La Nina or El Nino the previous year and those Kelvin waves that will transport those anomalies of that same sign up within the PDO horseshoe. And if they were driven by these weather patterns so much, then they wouldn't just have those perfect patterns of variability like that. And it just makes sense, too, that ocean water with a higher specific heat than the overlying air would evolve more slowly and then drive anomalies within the atmosphere immediately touching it. And also the jet stream here flows directly over the North Pacific, so it's not surprising that PDO horseshoe plays a big role in the teleconnections when you're looking at teleconnections versus El Nino and La Nina in the tropical Pacific. So a lot of those other factors you have to look at when you're looking at teleconnections out here, but I do think we have a favorable pattern for western U.S. troughs and an active second season for severe weather, and I do think that's going to continue into spring of 2022 as well. So thank you everybody for tuning into this long Friday night weather report. Hopefully you got something out of it. Basically, severe weather event coming to Oklahoma, North Texas on Sunday and expanding, including that area, but expanding north, Kansas, even into southwestern Nebraska on Tuesday. And then maybe a skinny squall line moving into some low cape, high shear type of an atmosphere, eastern Iowa into northern Illinois on Wednesday. So I'll be streaming live, full-blown storm chase mode happening for all of these setups. So thank you, Facebook supporters, for making that possible. Live briefings like this and my live storm chases are all powered by Facebook supporters. And if it weren't for you, I wouldn't be able to do all this. Live briefings, live streams, our science mission. So thank you, everybody. Have a good Friday evening. And I'm going to be hitting the road tomorrow, going live throughout my journey on the way out there. Never stop chasing.